Problem B, 8B, to be precise. Numerator, are you dizzy yet? Factor out what you can. Pull out a 6x squared. What's left behind? How about x plus 2? Does that do it? 2 times 6x squared is 12x squared. X times 6x squared is 6x cubed over. What about that denominator? Denominator, gross. Pull that negative out. Disgusting. And then, then we can say we're left with x squared minus x minus 6, which is much prettier, because I know that that will factor as x minus 3 times x plus 2. And I still have my factor of x plus 1 down there. Don't forget about that. And don't forget about that negative that we just pulled out. Pull that out front like so. And what do we have then? We have stuff. More specifically, we have a hole right there. So that is going to go away. And let's figure out what the y value of that hole is. The x value is negative 2. So what's the y value? Well, we'll have negative 6 times negative 2 squared is 4 over negative 2 minus 3 is negative 5 times negative 2 plus 1 is negative 1. Gross, Mr. Reed. Get a hold of your bodily functions. Well, negative, negative, those are canceled. So we have negative 6 times 4 is negative 24 over 5 is the y value of our hole. So we have a hole at negative 2, comma, negative 24 fifths. Notice that that is almost negative 25 fifths, which is negative 5. So we're just about at negative 5, but not quite there. All right, what else do we know? We know that we're going to have an x-intercept at 0. Boom, that's sick because of that x squared factor in the top. So we will have a y int at 0, 0. We know we will have x-intercepts at x equals 0, where it will bounce. Boom. And that's the only one. We know we will have vertical asymptotes at x equals 3, where the multiplicity is 1, and at x equals negative 1, where the multiplicity is also 1. So tails will always be on opposite sides there, no matter what. Ba-doo-ba-doo, 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 ba-doo-ba-doo. That's my arrow drawing sound. Okay, what else? Well, what's the degree of the top and the degree of the bottom? They're both x squared, which means our horizontal asymptote will occur at the coefficient, which is negative 6. So a HA at y equals negative 6. And I think that's everything we need to know. Scoop and plot them. Vertical asymptote at 1, 2, 3. Pop, 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 booty, dooty, doot, dop. And negative 1, ha la 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 la, shma la 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 la. And 0, x-intercept at 0, boop, right there, where I'm bouncing. Don't forget you're bouncing. And a hole at negative 2 and negative 24 fifths, which is like 1, 2, 3, 4, 5. It's like so close to 5. Let's make that a little bigger. Blap. And last thing, what do we know? Horizontal asymptote at negative 6. So bop, 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 like that. Now, let's sketch stuff in. Start where you know you will be. I don't know where I'm going to be anywhere. Oh, wait, what about to the right? To the right, notice that I don't have any x-intercepts over here, which means I have to be down like that. Because if I were up, I would cross the x-axis, and that would give me an x-intercept, and I don't have any there. So I have to look like that. Okay, well, the multiplicity on all of my asymptotes is 1, which means my tails are always going in opposite directions. So since the asymptote at x equals 3 is down to the right, it's up to the left. And I have to bounce and go back up like that. So I get that. That looks poopy. Let's do that again. Still looks kind of gross, but there we go. And again, my tails are opposites, so I have to start down here to the left and go up, cross that asymptote, hit that hole, and then I'm going to be curving back down to approach that horizontal asymptote, and we're going to call that our graph.